We have a fireside chat now with Leslie J. Allen and Claire Delaunay. Leslie is the news editor at Automotive News and editor of Shift VA, a magazine devoted to mobility and advanced technologies. In addition, she co-hosts the weekly podcast, Shift, a podcast about mobility. Welcome, Leslie.
How are you doing, Professor Talbot? Nice to be here.
Well, thank you. We're happy to have you. And next we have up Claire Delaunay. She's the Vice President of Engineering at NVIDIA, where she's responsible for Isaac Robotics. Claire has 15 years of experience in robotics and autonomous vehicles, leading teams ranging from startups and research labs to Fortune 500 companies. Claire holds a Master's of Science in Computer Engineering. Welcome, Claire.
Thank you very much. Good morning, good evening, everyone.
Hello. Leslie, I'll turn it over to you now.
Terrific. Thank you very much, Professor Talbot. And thanks to Velodyne Lidar for the opportunity to lead this discussion with Claire. I think this is a wonderful event, and I wish we had more than a half hour too, because Claire is, Congresswoman Dingell talked about seizing our rightful place at the forefront of the industry. And I can't think of a better example of that than Claire. So why don't we just get right into it? If you, I want to know, we have a lot of young people who are going to be listening in on this event, and can you give us some background on how you got into the field of engineering?
Yeah, so I went into the field of engineering a little bit by mistake, like a lot of young people, you know. At the beginning, you don't really know what you want to do, and you give it a try for a couple of years, and you see if you like it or not. And then very often the 2 first years is where you change a little bit career. So I was very lucky to end up directly in an area that I really liked. But it turns out I actually really started with I would say classical software engineering. Which is really related to building ERP system, big databases, and all of that. And it turns out I got a little bit bored. I wanted to expand my horizon, and so I really started. So I started building my own robots on the side in my apartment at the time, and applying to robotics conference. And that's how I got my first job in robotics. And so I didn't even have a formal training in robotics. But this passion that I pursued directly gave me this opportunity to join the right company and to really find my place. And since I did this move very early on, I never went back. And I've been in robotics since then.
So what attracted you to autonomous technology specifically? I mean, this whole field of self-driving vehicles. So how did you get into that?
I think it's a fascinating field because it's really at the crossroad between engineering, but also it's really close to understanding how we human beings and our world is working. Because when you think about it, it's all about capturing information from the real world, creating some kind of internal model about what's going on, and acting upon it. And so, and in robotics and autonomous technology, you are accomplishing this exact cycle. And I found it completely, so exciting to be able to do this parallel between how we live and understand, and try to reproduce this schema on a computer.
Now, some people might know you as the former director of engineering at Uber, and you arrived there via a company that you co-founded called Otto, which is involved with self-driving truck technology. So can you just give us a little bit on that and how you came to start that company?
Yeah, so I decided to start this company after really, so I already did self-driving cars back in Europe, even before Google started looking into it. I did a lot of robotics for consumer, for industrials, even for military. And so when I decided to create Auto, there was this also this environment that was very positive and really able to sustain such a startup. I would have created Auto, for instance, 5 years earlier. I think it would have been too early, just because the sensors were not there. For instance, the computing power was also not completely there, and the machine learning also was a little bit less powerful. And what really excited me in this startup is the opportunity to really apply a technology to a very concrete business problem. And that's really what excited me about creating this company. Self-driving for truck is a very well bounded problem, I would say. Truck drivers are driving the same highway sometimes multiple times a week. Like even multiple times a day if the highway is not very long, and they always drive the same route from one place to another one, just conveying the goods from one place to another one. So it's a very repetitive task, and it's a very and it also makes it very easier, I would say, to automate. And I was really excited by this idea that we have a very concrete business problem, and let's develop the technology to solve this problem. And I think it's very important if you want to create disruptive or really big evolution on the technological side. Having a very clear business proposition is extremely important. Otherwise, it becomes an open-ended engineering problem, and then you're chasing without having ever an end line or a final goal, which is much harder.
And of course, now you're with NVIDIA. For people who may not know, I mean, people may be familiar with NVIDIA from, let's say, the graphics chips that we're familiar with for video games and things like that. So can you give us a sort of a high-level overview of what NVIDIA is and your role there?
So NVIDIA originally is a chip company, but they pivoted also the last, I mean, since the beginning, I would say, I mean, it started as a chip company, but it was very clear from the founder, Jensen Huang, from the beginning that the hardware goes with the software. It's a little bit like if you have the brain, you also need all the software and the logic on top of it to actually make it useful to people. And so originally, NVIDIA focused a lot on gaming and everything related to digital content creation. But it turns out the last couple of years, I mean, even a little bit more, like the last, I would say, 7 years, we can see that the real world, capturing information from the real world and bringing it into a brain, requires very, very, very similar technology to what you would need if you create a fully virtual world. And so that's why I'm so excited to work at NVIDIA, and I joined this company because I can see that the future of programming brains, like intelligent brains, is going to be a mix between what we would qualify as a gaming experience or a simulation experience. A lot of work moving forward is going to be done on the computer and using techniques of digital content creation, simulation to accelerate the development and the training of these machines.
It's pretty interesting. Now, as you're working on your technology at NVIDIA, what are some of the top trends that you're seeing right now? I mean, we talked earlier about driverless trucks, for example. Well, self-driving trucks, I should say. What are some of the other trends that we're going to be seeing in the near future?
Yeah, so I think we're going to see more and more robots in our factories, in our environment, maybe on the sidewalk also. And the main reason for that is we are reaching a convergence point where the hardware is there, the sensors are cheap enough, and the technology is at a point where we are very close to be able to take all these tools out of the robotics hands into more applied areas. And this is always when the technology reaches that point, this is always when suddenly you have an acceleration. When the people programming the robots are not necessarily roboticists anymore, but have the real problem at hand. So understand the final value proposition. And the moment we are able to enable these users, then of course you have many more applications, and they are much more relevant to our daily problems.
Well, speaking of relevance to our, let's say, our everyday driving experience, we're hearing a new buzzword lately, software-defined vehicle. And I know that NVIDIA had an announcement last year, I believe, with Mercedes involving work on software-defined vehicles. So what is that, and why is that such a hot topic right now?
Yeah, so that's a very good question. Let me take an analogy. So I'm going to take the mobile phone as an analogy. So I would say the car before was more like a rotary phone, right? So I was not necessarily the most interactive interface, and it was hardwired, and you had it once, you buy it once, and if you want to upgrade it with the new functionalities, you have to buy another one. There is no way around. There's no connectivity. There's no like wireless. There is nothing. But now a mobile phone, our recent mobile phones, like 2 days ago, Google pushed an update to my phone, and suddenly they actually changed my UI. So it has also done, I would say disadvantages sometimes. But the great thing is that every single security patch update is also done directly on the phone without you even noticing. And we also take it for granted, right? So today it's a buzzword, software-defined car, but I would say that in the future, not being software-defined would be really weird.
Now, speaking of really weird things, there are a lot of misconceptions out there about autonomous vehicles. So as an engineer, if you could clear up one misconception that's out there, what would that be?
I think we're pretty far from full autonomy, where the car is really driving by itself and doing everything by itself without human control or supervision. And so and when people think it's very close, because we already see videos about the technology going on the road and all of that, what we have to understand is that the complexity curve looks like something exponential, which is, you make progress, you are at one point and you're like, oh my God, I'm like, we're gonna make progress in the very short term, in the next 2 years. But as it's exponential, it's actually not the next 2 years, it's gonna be in the next 10 years. And so that I think is very important to ground a little bit the investment, but also the policy making, as we discussed just before. We have to understand that self-driving cars are not fully self-driving just yet, and it's not going to happen overnight. And we have the time to prepare ourselves and to develop the technology in a way where we're going to gradually transfer our ownership of decision making to the car. And it's going to happen at the vehicle level, where we're going to train slowly by little your car, but also at a scale of a country, where we're going to also gradually deploy infrastructure and everything that is required to actually operate safely the technology.
Of course, you're going to have to convince the people on the road now that this might be a good leap for them to make. I mean, how do you build confidence in these vehicles? A lot of people are afraid, and studies have come out to say that people are nervous about self-driving vehicles.
Yeah, and I think it's mostly because the misconception is that these vehicles are completely self-driving. Now, let me take a very much more simple example. Let's say you have an auto park, that your car is able to always make sure you're never gonna bump on the car front and back, and you always gonna have the perfect motion, and without, I mean, regardless of the stress that you have around and all of that, it's gonna calculate the perfect trajectories, and you are in control, so you can stop the maneuver at any time. Well, this is a self-driving capability, but it's not, I mean, it's not fully, it's not scary, I would say, or it's going to be scary the first week, but then when you're going to understand how the system works, then there will be no fear anymore. Another analogy would be when a kid is presented with a big animal, a horse or an elephant or something that is out of the daily life of this kid. The first reaction is fear, because it's the other system, that the animal looks like unpredictable. But the moment there is some understanding and time passes, and there is some kind of, the human brain can build some kind of predict what the animal is going to do, or predict what the car is going to do, then we have this kind of confidence that is building naturally, because we understand and can predict the system. And I think this is something that is really well acknowledged now in machine learning in general, and of course specifically in self-driving. Repeatability and the ability to explain away what the car is going to do is very important to build trust.
Let's stay on this topic of machine learning for just a moment. And I'm curious about what are some of the cool things that are in our everyday lives right now that are driven by research in autonomous vehicles and AI and things like that, things that we might experience without even thinking about the underlying work that's gone into it, engineering wise?
Yeah, well, there's a lot of things on our phones, right? There's just the fact that you can be localized precisely with the GPS, knowing that the GPS is very noisy, that buildings are interfering with the GPS. I mean, there is a machine learning part in it that is able to crunch all this data, like the Wi-Fi signal strength, the GPS signal, the location you are in, the road you were in. It's going to fuse all of that and make sure that it's going to output the most likely location you are actually in. You also have, of course, all the ASR, all the voice recognition, Siri, which is really a machine learn approach, movies recommendation, advertisement recommendation also. Everything where the problem space is huge, and we have very, very abundant streams of data. It turns out machine learning is very good at just downscaling the problem, reducing the dimension to something that we can work with, an engineer can work with, I would say.
And I imagine that has made quite a change in your job just over the years, just seeing the development of AI.
Yeah, absolutely. It did change a lot the way we think about developing the system. So before that, we were really trying to go first with one single simple problem and try to build and craft all the features, and then expand slowly the spectrum of what we want to do to be able to make it more resilient to more problems. But now this is the opposite. This is the other way around. We collect massive amount of data, and we try to trim it down and to say, well, maybe this data is not so much relevant. So for instance, let's say you collect road data. Well, maybe you can, for now, you can remove the lane lines that would be, I don't know, painted violet or another color, and just focus on a certain type of lane lines that you really care about for your in your country, for instance. And so you really take all this data, extract what you think are the boundary condition of your problem, and then learn on top of it and see what happens. And then you iterate. So it's much more iterative, and it's much more about downscaling the data and make sure that you have a full understanding of the problem, instead of this approach where you slowly go from one solution to expanding slowly to other solutions. So it's very different, and it requires new tools, definitely.
Of course, our conference here is called Disruptive Women, Powering Our Autonomous Future. So I would like to know, just from your perspective, how are women disrupting this industry? How is their role changing?
So yeah, I think one of the advantage women have in this kind of fields is being a generalist helps a lot, first of all. So, and that's something in my experience I always observed, is that there's a lot of very talented women that can be engineering, is focused on engineering, yet understand the goal of this engineering. You know, why are you coding in the first place, or what is the intent behind an engineering task? And I found that it helps a lot disrupting the autonomous vehicle industry or autonomous machine industry, because you always have to think of an autonomous vehicle today as a system. That it's not only just one technology, one lane perception, or one machine learning. It's really a problem where everything has to work together. And we have to find, we're still at a phase where we need to find the magic answer on how all these things needs to be combined together. And so women in general can really think out of the box and really understand the final vision of the engineering exercise, and it helps finding the right shortcuts or defining the process in a new way. And one of the reasons why I think for once everyone is at the same level is also that is not something that you can learn at school. I would say it's common sense, but it's very hard to do if you have been formatted since you started your education to think a certain way. And so because we are women, and because we're usually always on the sideline anyway in all these traditional courses, well, we actually end up with an advantage because we already think out of the box. We already have been forced to really see the things differently and think about the engineering problem in a different way, because engineering today is mostly defined by men. So that's actually how you know, being on the sideline most of the time is actually now turns out to be a strong advantage. And I would say it works for autonomous machine, but it works for any disruptive field. I believe that women have a lot of opportunities in the fields that are yet to be consolidated. And it's great because it means we can also shape them.
And also shaping the path of AI, I would imagine, and making sure that the systems are trained in a fair way.
Yes.
Reflects women. Can you?
Exactly. That is totally true. That's a very good point.
Now, one thing I'm wondering about is, would you have any advice for women or for girls who might be thinking of going into engineering, and specifically into autonomous vehicle engineering?
Yeah, so the first line of advice would be that don't judge a book by the cover. So I found it, so I could have given up on engineering multiple times, but it turns out most of the time it was just a matter of changing environment, or changing company, or changing who I was working with. And so I think it's very important to remember that while engineering is engineering, the people you work with and the people who are mentoring you have a tremendous impact on how you're going to feel about the field. And so for people who are already in the field or considering it but are a little bit afraid, I would say just take the time to choose carefully whom you're going to work for, because it's going to have a tremendous impact if you like the field or if you don't like it. And if today doesn't work, take the time to potentially change place before changing fields. So that would be the first advice. The second one is that it is very important to build a generalist background in addition to become a specialist, or even before becoming a specialist. Because the moment you become a specialist, you have much less option also to be able to work on other, like, you know, surrounding fields. And so it limits your option to be able to reorient or change companies. And in addition, a robot is a very complex machine, and it requires a lot of understanding of different pieces. And building this kind of generalist background is really going to give you an edge in the end to make any kind of I mean, it's going to help tremendously to go in any kind of leadership position, in addition to engineering. And I think women in leadership position are very good because they are very focused on the product. So that would be my that would be my advice.
So you're speaking of the difference between being a specialist and being a generalist in engineering. So on a day-to-day basis, how is that different for you working on autonomous vehicles versus any other type of software or system?
Yeah, so in other type of systems, I would say, I mean, some of them are very complex, but most of the time, first of all, you don't have the real life component, right? So the system are just trapped in, I mean, I'm going to take the phone again, but they trapped in a phone. They cannot escape, you know. It's like, it's very limited, and you have a framework to program for Android, a framework to program for iPhone, and that's going to be about it. You can do many apps, right? But that's going to be about it. In robotics, so first of all, you have many sensors, and Velodyne, who is hosting us today, I mean, can speak for it, but it's one of the sensors, maybe one of the major sensors right now for self-driving, but it's only one of them. You need many sensors from many different, you know, companies. You don't have a framework also to develop. There's no existing framework. So you start, you can program in C++, you can program in Python for prototyping, you can do C, you can use so many different operating system, and there's so many decisions to make on how you want to build your car. And each of them have consequences, like the sensors, right? Each decision that you make to build a robot would have consequences. And so, and finally, you need to build algorithms that are doing smart things. And again, there's many ways to do things differently, many kind of algorithm. And they, of course, depend on the sensors that you choose. So you have this kind of giant, you know, a pool of things and tools you can take from, you can pick from. None of them is perfect yet because we're still shaping the field. And so being a generalist helps you finding shortcuts, like I was saying before. And that's the most important thing that we need to find right now in autonomous driving, finding the shortcuts, identifying the patterns and finding the shortcuts. And being a generalist gives you this power.
I want to go back a little bit into your background in robotics. I mean, I'm just curious about what drew you to robots. I mean, I think that's a really cool thing. Is did you start as a young person? You mentioned building robots and working with robots. Tell me about that.
Yeah. So, well, I mean, for the long story, I actually so I was doing my study in this general computer science school, and I did one internship in an hospital, and I was like, management system, information system is just, I don't feel like it. And so I applied to 2 places randomly. One was Antarctica.
Antarctica. Oh my God.
And the other one was on an island, Réunion Island, close from Madagascar, a French island, because I was not speaking English at the time. And we were studying a volcano, and they say yes. And it was to study a volcano. And so I went there. did my first part of the job, that was developing the intranet, which is just information system again, and did it as fast as possible so I can work on the tech part, which is building seismic station to detect where the next eruption would be. And that was really my first exposure with like this mesh network of sensors that are collecting information live around the island, and bringing everything to the observatory. I mean the brain, and we were crunching all this data and trying to make something out of it. And the process for me was just phenomenal. And I was like, that's it. I want to work on this kind of system. And if you think about it, this observatory was basically a robot at the scale of the volcano. And then, yeah, I started building robots on my in my garage after that. That's what really started all the process.
Well, that is fascinating. Unfortunately, our time has come to a close. I really want to thank you for
Thank you very much.
participating in this conversation, and I hope we get to talk again soon. So I'm going to turn it back over to Professor Talbot.
Thank you so much for that incredibly interesting discussion. We really appreciate having you both.